Hi, my dear students. This is like an introduction, so you can understand what a polynomial function is, okay? And which is the behavior of the polynomial functions. Now, look, the first case, we're going to see that this is a 0-degree polynomial. We have f of x equals 4 times x to the second. That's why this is a 0-degree, because the power of the x is 0. And remember, we have a theorem that says, let me write it here so you can remember about the polynomial, about the theorem. Here, the theorem that says that any letter or a variable or number raised to the 0 power equals 1. Okay, so don't forget about this theorem. Well, now, knowing that, we have that 4 is being multiplied by 1. So in the end, we have f of x equals 4. That's why we usually do not write the x to the 0 or the y to the 0 or any variable to the 0. And then this is the same as to say f of x or y. Remember? It could be y equals 4 or f of x equals 4. And if we plot the graph of this 0-degree polynomial in the coordinate plane, as you can see here, we have the x and the y-axis. And in the number 4 over the y-axis, we have a horizontal line in purple color. This is the graph of this 0-degree polynomial. Okay, this is a horizontal line. There is no slope. Okay, the slope is equal to 0. Then this is the first polynomial, but as you can see, we could have also different degrees as the first degree. But here we are going to study in this page, in these drawings that I have here, odd degree polynomial, a polynomial with a degree that is an odd number. And this is very important, dear students. Look, functions with an odd powers. So an odd could be first degree, third degree, fifth degree, and it can continue, okay? But I want you to remember the first degree is a linear function because it is y equals x, because the x is being raised to the 1 power, okay? And when the leading coefficient of x is positive, as we have here, all this left column, all the leading coefficients are positive in this left column. Check, the line is ascending, remember, because the slope is positive, okay? And the leading coefficient of the x, which is being raised to the 1 power. Now, let's see, besides, we have when the leading coefficient is negative, or the slope is negative in this case, okay? Also, this is y equals minus x. Also, the x is being raised to the 1 power, but the leading coefficient is negative, so we have a descending line. Then let's see the next case with the third degree. When the leading coefficient, which in this case is a, is positive. Look, the behavior, it is like the ascending line. It is falling to the left and it is rising to the right, okay? So look at the third degree. It is also falling to the left and it is also rising to the right. These are the ending behaviors of the polynomial functions, okay? But as this is a third degree polynomial, you're going to find 3 roots. If the 3 roots are real number roots, they are going to cross here, here, and here through the x-axis. And you're going to find 3, 1, 2, 3, because this is a third degree function. But look, dear students, if the leading coefficient is negative, it is like the descending line. As you can see, it is rising to the left and it is falling to the right. This is the ending behavior. Look at the third degree polynomial. It is rising to the left and it is falling to the right. Okay? And also you're going to find if 3 roots that could be real number roots, as in this case, because they are crossing through the x-axis. We have 1, 2, and 3. Okay, now let's see the fifth degree. Okay, and they are going to have the same ending behavior as the line, as you can see here. If the fifth degree polynomial if the leading coefficient of the fifth degree polynomial is positive, look, it is also falling to the left and raising to the right, okay? And then, as this is a fifth degree, we're going to find 5 roots. If all the roots are real number roots, all of them are going to cross the x-axis. Remember that you could find roots that could be complex numbers, and they are not going to be plotted in the coordinate plane, okay? Because in the coordinate plane, we just plot the real numbers that we find. But look, as this is a fifth degree, here we have 1, 2, 3, 4, and 5 roots, real number roots. But don't forget about the behavior. This is what I want you to focus right now, that it is ending in the left, it is falling to the left, and it is raising to the right as the line, as the linear function, falling to the left, rising to the right. Don't forget, this is important. Now, let's see. In the fifth degree, it is, as in the linear function, it is rising to the left and falling to the right. As you can see, it is rising to the left, falling to the right, with the 5 roots, 1, 2, 3, 4, 5. In case that the roots, in this case, all the roots are real number roots, okay? But now, dear students, look at the behavior of the polynomials when we have even degrees, okay? Remember, even degree could be a second degree, a fourth degree, a sixth degree, an eighth degree, and so on. But all of them are going to have the same behavior as the odd, degrees, okay? Now, let's see these ones, the even degrees. Look, the first one is a second degree function. This is a quadratic function. And check again, in the left column, we have when the leading coefficient is positive, and also in the right column, we have when the leading coefficient is negative. Now let's see. In the second degree, we have when the leading coefficient is positive, we have the parabola that opens upwards, as you know. And we are going to say that this parabola is raising to the left and also is raising to the right, okay? This is the ending behavior. And look, when the leading coefficient is negative, talking about the second degree polynomial, it is falling to the left and it is falling to the right because the parabola is opening downwards, okay? Now let's see the fourth degree. And look that they are going to have exactly the same behavior, ending behavior, as the parabola. As the parabola is raising to the left and raising to the right, look, when the leading coefficient of the fourth degree polynomial is positive, it is also raising to the left and raising to the right, okay? And as we have to find, in this case, 4 roots, because the degree of this polynomial is fourth degree, we have here 1, 2, 3, 4. If we talk about real number roots, in this case, yes, they are real number roots, okay? And then, when the leading coefficient is negative, dear students, the same thing as the parabola. As you can see in the parabola, the ending behavior is falling to the left and falling to the right. So we have the same thing with the fourth degree. And also it's going to be the same ending behavior for the sixth degree, the eighth degree, all the even degree polynomials, okay? So here we have, it is falling to the left and falling to the right with the 4 real number roots, 1, 2, 3, 4. Good, dear students, it is going to help you a lot. So please pay attention to this video because we're going to start solving some exercises later on. Thanks, have a nice day, take care, stay at home, and see you later. Bye.